All right, this is part B is another completing the square problem. So we have 2 over radical minus x squared plus 4x. So we have a quadratic in the bottom. So let's first tackle with the quadratic here. So minus x squared plus 4x. So we're going to complete it to a square. Generally, when we have x squared coming with a negative coefficient, so we pulled it out first. Okay? And now I have x squared minus 4x. Okay? So I'm going to apply the same strategy here. The minus out, obviously, I'm not touching that. So in the bracket, I'm going to have x plus the half of the coefficient of x. But the coefficient of x is negative, so the half of that is negative 2. So this term here is going to be the perfect square of x minus 2. Okay? Normally it's like x plus the half of the coefficient, but the coefficient is negative 4. Half of that is negative 2, so it becomes x minus 2. So I want to first know what's going on here to match it up back to x squared minus 4x. So here, x squared minus 4x plus 4 is the expansion of the perfect square. In the original polynomial inside the parentheses that I started with here, right? This is the original polynomial to start with. I have x squared minus 4x, and I didn't have any 4 extra. So this 4 extra should be compensated here. So I should probably subtract that 4 and finish up completion the square. Okay? So this is my way of handling it, and you can use different ways, different formulas if you want to, as long as you get to the final form. I'm completely fine with that. Okay, so since we're done here, let me just copy that down here. So this integral is equal to 2 dx divided by radical minus x minus 2 squared, and let me just put a bracket here, and minus 4 here. I'm going to simplify that in a sec, but I just wanted to copy everything down back up here. Okay, so I don't need this part anymore, so I'm going to sort of like erase this whole thing and continue tackling with the integral, which is what we started with. Okay. Well, first of all, let's get rid of the minus sign inside the radical. So let's just expand this all out. Okay, so it's minus x minus 2 quantity squared plus 4, right? I want to write the 4 first. 4 minus x minus 2 squared. And this is, in fact, the same as 2 squared minus x minus 2 squared in the bottom. And don't forget to put the radical, okay? All right, so I have a number squared minus a variable squared. This is one of the known forms in the table of integrals involving inverse trig function. In fact, this is the very first integral here. So du over radical number squared minus variable squared. So this in fact tells us what to call u in this problem. So here we go. I have a to be 2 and u to be x minus 2. So that calls my u substitution to be u equals x minus 2. Now looking at the differentials of both sides, you have du equals dx. Great. So I'm going to rewrite this in terms of the brand new variable u. So 2 times du, and on the bottom you have a squared minus u squared. Okay, so let me just go back to the formula again one more time to grab what this integral is equal to. So it says arc sine u over a plus c. Okay, so going back here, this is equal to arc 2 arc sine, in fact, u over a plus c, because I still have this 2 here, right? You could also pull that out, right, out of the integral. So put the 2 over there. So this is 2 arc sine u over a plus c. and u is originally x minus 2, and a equals 2. That makes this whole thing to be 2 arc sine x minus 2 over 2. Okay. All right, so we're done with both parts of this exercise. Completing the square, please solve more problems to get used to how a quadratic is completed to a square. There may be different versions of that, so please practice on your own. And that makes the end of the video. Thanks for watching. I'll see you in another video. Bye.